Alright, so let's take a look at this video, and well, as you can see if you clicked on the video, this is going to be a long video, but I'm going to go through all the possibilities that you'll come across, and hopefully after this video you'll understand it. Okay? Alright, so just bear with me and try to watch the whole video. Alright, so let's consider a binomial distribution where n is the number of trials, r is the number of successes, p is the probability of success on a single trial, and q, which is 1 minus p, the probability of success. So q would be the probability of a failure if it's 1 minus the success on a single trial. And if n times p and n times q is greater than 5, then r has a binomial distribution that is approximated by a normal distribution with the mean mu is equal to n times p and the standard deviation sigma is equal to the square root of npq. Alright, so let's look at this, and I know that if you've had this in class before, then you're aware of the continuity correction. Do I add 0.5 or subtract 0.5? Now, the way I'm going to explain this is hopefully you will not have to memorize whether to add or subtract the 0.5. I'm going to show you a way to where you're going to understand it, and you can just sketch a picture real quick and see whether you have to add or subtract the 0.5. Alright, so just bear with me for just a second before we get to the problem so I can show you what's going on. Alright, so here's a binomial distribution table, okay, part of it. Okay, it's 8 through where n is 8 through 11, but that doesn't matter. So let's just look at this. Alright, so you see these little areas here, these sections here. Okay, if we plot these, see where r is 0, 1, 2, 3, all the way to 8. So if this goes along the horizontal axis, the 0 through 8, and then these probabilities over here, they go up here, and let's just say at 1 we're at what, 0.267. So let's just say that's 0.267, and then at 3, so that would be 2, and then we would go here to 3, that would be 0.311, so that would be a little higher like this. And if we continued on, we would get a histogram. A histogram. Okay, and these little rectangles here represent areas. Okay, now the larger that n gets, okay, so if we use 8 or where n is 5 or n is 3, something like that, and we graph these things, this little histogram here, it may not look like a normal distribution. Okay, but what happens is the larger n gets, the better that this gets to be a normal distribution. Okay, so it's better when n is larger. Okay, so here's one where n is about 12. Okay, something like this. So if we plot this, you can see it kind of takes on a normal distribution. Okay, now this is where it comes in. Okay, the continuity correction. So let's look at this. Let's suppose, okay, and I know this n here, it's not that big. I mean, when you're dealing with these types of problems, you may be dealing with n is 100 or n is 60 or something like that. Okay, but let's just look at this where n's about 12. Okay, all right, so let's suppose we want the probability that r is greater than or equal to, say, 7. Okay, now remember, r is our discrete random variable, but what we're going to do is make a continuity correction to our continuous random variable, x, okay, for the normal distribution. All right. So if you look at this, you can see that r is greater than or equal to 7. So there's 7 right there. And what do we want? We want this area to the right. You see that? But what's happening is we're taking in this part of the curve. You see that? We're taking in that part of the curve. But do you see this part here that we're leaving out? Okay. See, we've got to come back and take in this entire rectangle here. So in this case, to get r greater than or equal to 7, so when we change it to the continuous random variable, we have to do what? We have to back up to here. And see, we back up 0.5. All right, to take in this entire rectangle here. So this would be equal to the probability x is greater than or equal to 6.5. All right. So that's how you'll determine if you're going to subtract or add. Okay, you can memorize all this stuff, but it's so much easier just to draw this. Okay, now the way I'm going to show you is we're not going to worry about drawing the entire thing. So what I would want to do if I was going to work this problem, I would just come up here, draw my number line. Well, there's the 7, and I'll draw that rectangle there. See, all I'm doing is just pulling out this thing right here, because that's all I need to see if I need to add or subtract. So you see, I'm just going to draw this one little box here because I know I need r greater than or equal to 7. So that's going to be everything back this way, okay, from here back to the right. Well, what do I need to do? I need to back up to here to take in this part. So I'm going to have to subtract a half. So I'll have to subtract back to 6.5. And that's what I'm talking about when I say just sketch it real quick. Just sketch that one box that you need. Okay. If it's between two numbers, well, sketch each number and put a box over it. Okay. And the examples are going to, we're going to do that in the examples. So let's go ahead and get started on the example. Now you can see here I've got 1, 2, 3, 4, 5 of them here. Okay. Now you need to watch these because if you notice here, all right, well, let's just read the problem. It is stated that 80% of all new products introduced into grocery stores fail within 2 years. Okay, if a grocery store chain introduces 66 new products, what is the probability within 2 years 47 or more fail? Okay, so in this problem, failing, you see this fail, that's the probability of a success. Okay, so the product to fail is a success. But notice these problems down here, it's the probability 15 or more succeed, fewer than 10 succeed. All right, so we're going to have to do something a little bit different. And like I said, this right here is pretty much going to hit everything you're going to come across. So, try to watch all of them. And I know it's going to be a long video. Okay, all right, so let's see what we've got to do here. All right, so we need, first we're going to do what? We're going to check and see if n times p and n times q are both greater than 5. All right, so we know here, we know that p is equal to what? 0.8, because it is stated that 80% of all new products introduced into grocery stores fail within 2 years. And then I need q. Well, q is 1 minus 0.8. Remember, 1 minus p, which is 0.2. So there's p and there's q. So now let's look at this. I've got n times p is equal to 66 times 0.8. Let me write this up here. N is 66. All right, so let's see, 66 times 0.8 is 52.8, which is larger than 5. So we're good there. Now let's check N times Q. Well, N times Q is what? 66 times 0.2. So 66 times 0.2 is 13.2, which that's larger than 5 also. So we can use the normal to approximate this binomial. Okay. All right. So what's the next thing that I need? I need what? I need the mean and I need the standard deviation. All right. So the mean is N times P, which actually we've already calculated that. So that's 66 times 0.8, which is 52.8. And then I need the standard deviation, which is the square root of N times P times Q. So square root of all that. So let's see. 66 times 0.8 times 0.2. And then I need to take the square root of that, which is, it's a big long number, but I'm going to round it to 2 decimals. So it's 3.25. That's the standard deviation. All right, so now, I've got everything I need. All right, so let's work the first part of the problem. Let's do part A. All right, so I need the probability that 47 or more fail. Now remember, this is a binomial, so I'm going to use my discrete random variable R. 47 or more fails, so that's greater than or equal to 47, okay, which equals, now what do I need? Well, I need to change this to my continuous random variable. I've got to do my continuity correction. So I'm not gonna plot that histogram of 66 where N is 66 and have 66 bars going across there, am I? No. All I'm concerned about is this 47 here. So I'm just going to mark 47 here on the number line and draw that box. I don't care how high I draw it or what. Okay. Now, what do we need? We want R to be what? Larger than that. Okay. Now remember, 46 is going to be back here and 48 is up here. Okay. So I'm from 47 to the right. But what do I have to do? I have to back up to take in this part of the graph. So I have to back up a half, 0.5. So this is going to be the probability that X is greater than or equal to what? Well, if I back up a half, that's going to be 46.5. Everybody, okay? All right, so hopefully that makes sense. And now what do I have to do? Now I have to what? I have to convert to my z-value so I can look it up on the normal distribution table. Alright, so remember, this is the probability that what? That z is greater than or equal to, so remember that's going to be x minus mu, so minus mu, which is 52.8, over the standard deviation. Okay. So this is going to be the probability that z is greater than or equal to, alright, so that's negative 1.94. I'm rounding it to 2 decimal places. Okay. So now we have to look this up on the normal distribution table. So remember, this is a z-value now, so there's the mean. So I'm back here at negative 1.94, and I'm looking for the area to the right. Okay, so this is going to equal, now the table that I'm using, when you look up the z value, that gives you the area to the left of the z value. Okay, so when I look this up and I get the area to the left, I've got to do what? 1 minus this area here to get this area here. Because remember, then the area under the entire curve is 1. So that's going to be 1 minus, and remember, when I look this up in the table, that's going to give me this area. So remember, this area here is 1 minus this area. All right, so let's look up the negative 1.94. Let's see. Erase this. That's from another video. So I've got negative 1.94. So negative 1.94.0262. 0.0262. 0.0262, and so that's going to be 1 minus 0.0262, and so that's going to give me 0.9738, and that would be my probability. Okay, all right, so let's look at the next one. It's going to be just a little bit different because it's not including the 58. So, and then we got one in between, and then we've got one where it's the opposite of what they're giving us for the probability of success. I'm going to pause while I erase this. All right, so now let's look at part B. Okay, so we want the probability fewer than 58 fail. All right, so I've got the probability that R, that's my discrete random variable, fewer than 58, so that's less than 58 fail. Okay, now this is, something you can do here. You don't really have to, but I think it makes it easier for you to convert it to use your continuity correction. Is I like to do this. Well, let's just come down here and put the 58. Okay, now I want to do less than that. Okay, so right here would be what, 57. This less than 58 would be the same thing as the probability R is less than or equal to 57, right? So you've got this and you've got this box. Okay, well, if I'm less than 58, that's doesn't include any of this. It starts here and goes back to the left. You see that? So that's why I changed it to the 57. I know that looks like a 6, doesn't it? All right. So now let's do our continuity correction. So I'm what? I'm less than 57, so that's everything back this way. But I have to come back this way to pick up this part of the rectangle. So I need to do what? I need to add 0.5 to the 57. So that's going to be the probability that X is what? Less than or equal to 57.5. All right. And so now we've got to convert it to our z-score. So that's the probability that z is less than or equal to. So that's going to be x minus mu, 52.8, over the standard deviation, 3.25. And so that's going to be the probability. Let's see, 57.5 minus 52.8, and then divide that by 3.25, and so that's going to give me the probability that z is less than or equal to 1.45. Okay, all right, so if we draw, and this is the last time I'm going to draw the z table out and look it up. I'll just put the answer from now on, because I mean, you should know how to do this by now. looking this. Well, I might do it on this one, and then on these two I won't. All right, so there's 0. Here's your 1.45, and I'm looking for the area to the left because it's less than. So remember, the table I have, I'm finding the area. When I look up the z-value, that gives me the area to the left. So let's see, let's go to our table, and we need the positive z-scores. And I forgot what my z-value is. Let's see, 1.45. Okay, so 1.45. So that's going to give me 0.9265. So 0.92 65. All right, and that's your answer right there. All right, so let's look at C, and I'll pause the video while I erase this. All right, so part C. So we want between 25 and 36 fail. All right, so we've got the probability between 25 and 36 fail. So R would be between 25 and 36. Okay, so actually on this one, between 25 and 36, there might be I think there's a different way to interpret it, than what I've written down, where you don't include the 25 and the 36. Okay, where it's everything, between the numbers, or you can say, well, it's between these two numbers, but it's also including them. Okay, so that's something you might want to discuss with your teacher. The book that I'm using, I looked at one of the examples they have in the section. They give a problem between the two numbers, and they include the two numbers. I might suspect some books might not include it. So just pay attention to what your teacher says on that. But the whole point of this is to get all this other stuff right too. This can be easily changed and just reworked. All right, so let's look at this. So we're including the 25 and the 36. We've got to make our continuity correction. So let's look at that. So, well, there's two of them, so 25 and 36, and let's draw our boxes here. Okay, so I've got everything between these two values here. But you see what's happening. I'm missing this and I'm missing this. Okay, so you can see, to take in this part of the rectangle, and then I got to take in this part of the rectangle. So this would be what, 24 back here, this would be 37 here. So I would actually, to come here, I would have to go back to 24.5, and to take in this rectangle I would have to do what? Go up to 36.5. So now making our continuity correction, that's going to be 24.5 is less than or equal to x, less than or equal to 36.5. And then we need to take this, convert it to our z-score. All right, so that's going to be 24.5x minus the mean, 52.8, over the standard deviation, 3.25, less than or equal to z, less than or equal to, now this one, 36.5 minus 52.8 over 36, I'm sorry, not 36, 3.25. All right, so then we'll have to plug all this into our calculator. All right, and so this is what we get when we plug it into our calculator. So this might not have been the best example, and actually I'm kind of glad it worked out like this, because for these to get accurate solution, you would actually have to calculate these z values in Excel. I mean, you would get something probably really close to zero. But if you remember how to calculate the areas here, well, there's 0, there's our normal distribution, so we've got negative 8.71 and we've got negative 5.02, and we're looking for the area between these two. So remember, you would look up this area and write it down, and then minus, look up this area and write it down, so you would subtract the two. But actually this is just the area to the left of this value is 0 minus, and then the area to the left of this value is also 0, and so your probability would be 0. See, if you look at the table, see the negative 5 and negative 8 aren't even on here, and the table tells you for values of z less than negative 3.49, use 0 to approximate the area. So, but you would get a more accurate result if you used Excel. I don't know, you may have to take it out to a bunch of decimal places in order for it to show something. But anyway, that's how you do it. Okay, so let's look at this next one. I'll pause while I erase it. Alright, so let's look at this one. It says the probability 15 or more succeed. Okay, now this changes everything. Okay, alright, so now see, before a success was when it failed, but now a success is when it succeeds, because that's what we're looking for the probability of. So what that does is that is changing all of this. So now, well, since a success is for it to succeed instead of failed, the probability of success is what? 0.2. So P is 0.2 now. Okay, let me write that in green. 0.2, and then the probability of failure is 1 minus 0.2, which equals 0.8. All right, so now we got to find n times p. Well, now p is 0.2, so this is going to be 0.2, and I'll have to recalculate this, which actually we have it here. That's what, 13.2. And then I've got to do n times q, which that is n times 0.8. Okay, these things here, they just swap, and so that's what, that was what, 52.8, 66 times 0.8, and now our mean n times p is what, 13.2. Now our standard deviation is not going to change. Yeah, this will be 0.2 and this will be 0.8, but it's still going to come out the same when you multiply them. Okay, so now we can work it just like we did for the failure. Okay, so I've got the probability that R, so 15 or more succeed. So that's the probability R is greater than or equal to 15. And then we've got to make our continuity correction, so we'll just draw the 15 real quick and the bar over it. Okay, now I want to go greater than, so that's everything back this way, right? But I've got to come back 0.5 to take in the whole rectangle, so that's going to be x is greater than or equal to 14.5. Okay, and so now we got the probability that z is greater than or equal to all right, so now we got to convert this to a z-score. All right, so remember, it's x, which is 14.5, minus the mean, which is 13.2 now, because we're dealing with to succeed, and that's over the standard deviation, 3.25. And so that would give us the probability z is greater than or equal to 0.4. And then once again, we look this up. That's 0. There's 0.4. We're looking for the area to the right. So when we look up the 0.4, that gives us area to the left. So we got to do 1 minus that area. So if we look up 0.4, let's see, 0.4, that's 0.6554. 0.6554. 0.6554. And 1 minus 0.6554, that is equal to 0.3446, and that's your area there. Okay, now let's look at the last one. Alright, so the last one, part E, so we need the probability fewer than 10, so that is R less than 10. Now, remember what I said, let's change this to less than or equal to. And so we've got the 10 here, okay? But we want less than that, so that's actually going to take us down to the 9. And so that would be the same thing as the probability R is less than or equal to 9. All right. So if I go to the left here, that's what I'm looking for, but I've got to back up 0.5, right, to take in the entire rectangle. So that's the probability x is less than or equal to 9.5. All right. And then we convert that. Probability z is less than or equal to, so that's x minus the mean over the standard deviation. And so that's going to be the probability z is less than or equal to, so I've got 9.5 minus 13.2, and that's divided by 3.25, and so that is negative 1.14 if I round it to 2 decimal places. And so there's 0, there would be negative 1.14, and I need the area to the left. Okay, negative 1.14, negative 1.14, so that would be 0.1271. So that would be 0.1271. Alright, so finally we're finished. If you stayed with me the whole video, I appreciate it. Check out my other videos. Give me a like, share, and subscribe, and thanks for watching.